everyone, welcome to Deeksha Vedantu. I'm your physics teacher Aditi, and today we are going to look into top 10 most important, most repeated numericals of the chapter Light. I know it is a high weightage chapter and a lot of questions from this chapter will be numericals. So take a seat back, relax and revise these numericals. We'll go from basic to extreme, from easy to hard, all kinds of numericals we see, okay, and they will include all the concepts. Now before that, I've got you a cheat sheet for the numericals of the chapter Light. This table has all the information about all the cases of ray diagrams, right? Image formation, so object position, image position, size of the image, nature of the image, as well as sign convention for each case of concave mirror. And not only concave mirror, for convex mirror, for convex lens, and for concave lens as well. This sheet is going to be very important. If you have any kind of problem, if you are confused for sign conventions, I have made a video for that. Go watch that, how to understand, how to revise those, how to remember those, okay? So these sign conventions are very important for your diagrams, so keep in mind and revise them properly. Now let's look into the very first numerical of the day. As you read the numericals, write down whatever you read, okay? A convex mirror used for rear view. What it is given? Exactly. A convex mirror. Every time you see what kind of mirror is given, write it down, because that will make 0% your chances of making a mistake, okay? For rear view on an automobile has a radius of curvature of 3 meters. So we are given that the radius of curvature is 3 meters. Then the bus is located 5 meters from this mirror. So the bus here is my object. This is the mirror, let's say, and this is the bus. So bus here is the object and it is located 5 meters from the mirror. Correct? So object distance will be what? It will be 5 meters. Now look into the signs. Now we have convex mirror. We have written it down. Now sign of u or object distance is always negative. We know that much, right? Now r is given, but we need focal length, which is 1/2 of radius of curvature. So focal length is r/2, correct? That is 3/2 meters. Understood? And we know for convex mirror focal length is positive. So this is all the information that is given in the question. Now they've asked us to find the position, nature and size of the image. So first we have written the given and we need to find the V, right? The position and nature and size of the image. So let's start with the very first. Now I have F, I have U. I can easily find V using what? Using mirror formula, right? So mirror formula says 1/F equals to 1/V plus 1/U. Very easy. Now I have F, right? So I can just put 1/3/2, correct? 1/V is what I have to find and 1/U is -5 meters. So I'll write -5 here, right? Just to find V now, we can just directly find V. Easy calculation, right? Plus 1/5. Just take the LCM, it will be 15 and 10 plus 3 equals to 1/V. So from here, 1/V will be what? 1/V will be 13/15. Understood? 13/15, and V will be 15/13, which is approximately 1.153, okay, and meters. So this is my distance of image. Understood? Now I found the position, right? Then they have asked me the nature. Nature, ma'am, it's very easy. In case of concave mirror, I need to use my brain. In case of convex mirror, it is directly, convex mirror always forms virtual and erect images. Understood? Convex mirror always forms virtual and erect images. Now they've asked us the size of image. How will we find the size of image? I have V, I have U, I can find the magnification, right? So magnification is minus V by U in case of mirrors, right? So magnification is, V is what? V is 15 by 13, right? And U is what? U is minus 5. Understood? This is not the sign here. Okay. So what we can do, minus 15 by 13 divided by minus 5, right? So this plus sign cancels, this cancels, 3. So my magnification will be around 3 by 13, which is around 0.237 something, 0.2307. Right? So my image will be smaller than the size of object, which is exactly the case of convex mirror, because we know in case of convex mirror the image formed is always diminished. Understood? First numerical done. Moving on to the second one, we have, yes, an object 4 centimeter in size. As we read, we write an object 4 centimeter in size, correct, is placed at 25 centimeter. So U is, now U is always 25, so this is minus 25 centimeter in front of a concave mirror. Now we are given a mirror that is concave mirror. Understood? Then of focal length is also given 15 centimeter. Focal length is 15 centimeter. What distance from the mirror should a screen be placed in order to obtain a sharp image? That means we have to find the where the image is formed, at where the screen should be placed. So the image is formed at there. So we need to find. Understood? Find the nature and size of the image. So this is what is given to us. Understood? Now, since we have written everything, now we'll see the signs. For concave mirror, focal length is always negative. For concave mirror, focal length is always negative. So here we'll put a negative sign. Okay. So I have U, again I have F. I can find easily the position of the image. So we need to find where the screen should be placed. That means position of image. Okay. Using mirror formula again. Mirror formula says 1 by F equals to 1 by V plus 1 by U. Very easy. 1 by F is minus 1 by 15. So minus 1 by 15 equals to 1 by V is what we have to find, minus 1 by 25. Understood? Now you just have to solve the math. Why is this getting gayab? Okay. Minus 1 by 15, just a minute, minus 1 by 15 and plus 1 by 25. Okay, so this LCM will take around 75, minus 5 plus 3 equals to 1 by V. Understood? So from here 1 by V will be minus 2 divided by 75 and V will be minus 37.5. And now keep in track what are the exact units. Here the units are centimeter. Correct? So this is the final position of my image. Right? Understood? Okay. Then we have to find the nature. Now this is a concave mirror. How will we find the nature? We also have to find the size. So we'll go find the magnification. Correct? We will find the magnification. How will we find the magnification? Ma'am, formula is very simple. It is just minus V by U. Understood? Minus V. Minus V is minus of minus 37.5. Divide by U is given as what? U is minus 25. Understood? So this is around, I'm guessing, 15. That will be 1.5. So magnification is minus 1.5. Understood? Clear? Easy. Now magnification comes out to be minus 1.5 and we are given the size of object. Again, there is a one more formula of my magnification, right? That is what? One more formula of the magnification is height of image divided by height of object. Correct? So here I got minus 1.5, which is then equal to height of image I have to find, and height of object is given to be 4 centimeter. So height of image comes out to be what? 0.6. It comes out to be minus 6 centimeter. Height of image is minus 6 centimeter. Understood? Everyone? Okay, so we found what we have given. We found the image position and we found the size of object, and since the magnification is minus, magnification is negative. When magnification is negative, then the nature will be real and inverted. Understood? The nature will be real and inverted. So these are the three answers we wanted: position, height of image, and nature of image. Correct? Moving on to the next question. A concave mirror produces 3 times magnified real image. So we have magnification is given as 3. Now to decide the sign of magnification, we need to carefully read the numerical. It says real image. What kind of 3 times magnified? Real image. For real image, magnification is always negative. Okay, of an object placed at 10 centimeter. Object is placed at 10 centimeter and u is always negative. We know that. In front of it, where is the image located? Basically, very easy question. We need to find where the image is located. So magnification formula for a mirror is simply minus v by u. Understand? And magnification is given as minus 3, right? U is given as minus 10 and V we have to find. This is what exactly is given. Now we can just solve it. It will simply come out to be 30 and the units are centimeter. Understood? And we have a negative sign, so this will be minus 30 centimeter. Correct? Okay, moving on to the next question. Light enters from air to glass. This is air and we have a, let's say, this is a glass. Having refractive index 1.5. So the refractive index of glass is 1.5. Understood? What is the speed of light in glass? We need to find the speed of light in glass. The speed of light in vacuum is given as, in vacuum that means air, okay, 3 into 10 raised to power 8 meters per second. Understood? So we just have to find the speed of light in glass, and it is the speed of light in air is given. Simply we have formula refraction of glass with respect to air, that is Ng divided by Na. Correct? Refractive index of glass with respect to refractive index of air. Now its relationship with velocity. Refractive index is inversely proportional to velocity. So that will be Va divided by Vg. Understood? Now Ng is given, that is 1.5, and Ng by Na, the whole thing is given. Okay, we are given Ng with respect to Na. Okay, equals to 3 into 10 raised to power 8 divided by Vg, and from here we can easily get the value of velocity in glass, velocity of light in glass, that is something like this. So from here we'll get 2 into 10 raised to power 8 meters per second. This is what? This is velocity of light inside a glass. Understood? Very easy. Okay, moving on. A student wants to obtain an erect image of an object. A student wants an erect image. We want an erect image. Correct? Using a concave mirror. Now he has to use a concave mirror, right? Of focal length 10 centimeter, whose focal length is given as 10 centimeter, and we know the focal length of concave mirror is minus It is always negative. What will be the distance of the object from the mirror? They are asking v, value of v, but in this case we are not given value of u. So we just have to tell them where the image object should be placed, where the object should be placed. Now this is my concave mirror, right? And in case of concave mirror, see, this is my concave mirror. Now this is the focus and this is the center of curvature. In only one case erect image is formed. Virtual and erect image is formed in only one cases, that is between focal length and principal axis. So we can simply write the answer to this as what? We can write that the image will be formed between, the object should be placed between focus and pole of the mirror. Correct? It should be placed between focus and pole of the mirror. Okay, moving on to the next question, we have a concave lens. We are given concave lens now. Make sure to write lens or mirror with this. Has focal length of 15 centimeter. So its focal length is 15 centimeter. At what distance should the object from the lens be placed? We have to find u now, correct? So that it forms an image at 10 centimeter from the lens, and image distance is given, that is 10 centimeter from the lens. Also find the magnification produced by the lens. Now in case of concave lens, the focal length is always, for concave mirror and concave lens, the focal length in both cases is negative, right? And in concave lens, remember concave lens is similar to convex mirror. So image is always virtual and erect. And if image is virtual and erect, in case of concave lens, if the image is virtual and erect, that means it will form on left hand side of the lens. Understood? The image will be formed on left hand side of the lens. That means it will be minus 10 centimeter. Understood? Also we have to find the at what distance should the object be formed. So we have to find the object distance. Correct? This we have to find. Now let us see. Now here, instead of using mirror formula, we will be using lens formula, right? Okay, so we will be using lens formula that says 1 by f equals to 1 by v minus 1 by u. Now 1 by f is given, that is minus 1 by 15 equals to 1 by v is also given, that is minus 1 by 10 minus 1 by u. If you just solve this from here, this is minus 1 by 15 plus 1 by 10 equals to minus 1 by u. If you take the LCM, this will be 150 minus 10 plus 15 equals to 1 by u and minus 1 by u. Okay, remember to put minus. Now if we just solve this from here, right, this will be 5 by 150, right, equal to minus 1 by u, and then this will be simply 30. So 1 by u equals to 1 by 30, so u equals to minus 30 centimeter. Understood? Centimeter is the correct unit. U equals to minus 1 by 30. Also find the magnification. So we also have to find the magnification. Let's see what the magnification comes out to be. For magnification, in cases of lens, magnification is not minus v by u, it is plus v by u, right? Now v is given as minus 10 and u comes out to be minus 30. So my magnification comes out to be 1 by 3. Understood? Magnification is 1 by 3 and u is minus 30 centimeter. Correct? Moving on. Next question says, if the image formed by spherical mirror for all positions of object placed in front of it is always erect and diminished. So my image that is forming by a mystical spherical mirror, it can be either, okay, it can be either concave lens or concave mirror or convex mirror. So the image is always erect and diminished. Then what type of mirror is it? Now this is very easy, ma'am, we know. In case of concave mirror, we know even enlarged images are formed, but only in case of convex mirror. Only in case of convex mirror, the image is always erect and it is always diminished, right? Okay, moving on. The next is draw a labeled diagram to support your answer. So the labeled diagram is, we have to show this is my convex mirror, understood, and then this is the principal axis, right? Now we have to show that the image will always be diminished. So if the object is placed anywhere between infinity and object and optical center, let's say this is my object, right? So this is the first ray that will be going parallel, right? It will be going parallel, and let's say this is the focus and this is the center of curvature. So the first ray will be going parallel and it will be coming back something like this, right? But it appears that it is passing through focus, right? Understood? Then the other ray that will be going towards the center of curvature, something like this. And since we know when it goes into the center of curvature, okay, let me just erase this, that I can't. Okay, yep, it will go towards the center of curvature, right? But it will bounce back and it will come back and follow the same path, right? It will follow the same path. See, something like this. Okay, it is following the same path back, but if we extend it behind, it will look like it is passing from center of curvature. Understood? A clear, concise diagram. Understood? So the rays where these are meeting, this will be my object. Oops, wait, this is my object. Understood? That red one, sorry, not object, this is my image. The red one is the image. This is the image and this is my object. So this is clearly visible that the image is definitely smaller than the object and it is erect, right? Okay, moving on. Next question says, in your laboratory, you trace the path of light rays through a glass slab. We have a glass slab and we trace the path of light, right? This is, let's say, a glass slab. Trace the path of light for different values of angle of incidence. In each case, measure the corresponding angle of refraction, angle of emergence. On the basis of your observation, your correct conclusion is. Before doing that, let us just see how exactly the path of light is being followed by our ray of light. Okay, so this is normal. Let's just draw a normal first. Carefully draw the diagram. You have to be careful, okay, here. Okay, so this is the incident ray that is coming. Okay, it is striking, making the angle of incidence. Then instead of going straight, it is bending towards the normal. It is bending towards the normal. Understood? Yep. So this is the normal first. Let me draw this. Now we have an incident light, right? This is the angle of incidence, and instead of going straight, it is deflecting towards the normal, right? So this is the angle of refraction. Again, make a normal at this point now. So this will be what? If you make a normal at this point, now the ray is traveling from denser to rarer, so it will go away from the normal, making an angle of emergence. Now we definitely know here angle I is always almost equal to angle of emergence, and we can clearly see here angle I is greater than angle R, correct? Let's see the options. Angle I is more than angle R but nearly equal to angle E. First option is correct. Angle I less than angle R, not correct. Angle I is more than angle E, that is not correct. Angle I is less than angle E, again not correct. Okay. Now next question says, this is our 9th question I'm guessing. Okay, so it says a student focused the image of a candle flame on a white screen using a convex lens. He noted down the position of candle screen and the lens as under. So see carefully, here we are given the position of candle as well as the position of lens and position of screen. So they are giving all this from origin. Let's make a system first. Okay, let's see, let's say this is a system. Okay, is it? Yes, and right. Okay, so they are saying from this origin the position of candle is 12 centimeter. So somewhere here will be my candle, correct? It's a red colored candle. Okay, then we have position of convex lens. Now this is what? This was 12 centimeter. Okay, now the position of lens is, convex lens is what? 50 centimeter. So this hole will be 50 centimeter. Understood? And position of screen is 88 centimeter. That means the position of the screen will be somewhere here. So from here, from origin, the screen will be, the screen is 88 centimeter away. Understood? Now they are asking is, what is the focal length of the convex lens? For focal length we need object distance and image distance. Very easy. So object distance will be the distance between this candle and this lens, right? So that will be 50 centimeter minus 12 centimeter, correct? So the object distance will be between the candle and the screen, right? That was what? This 50 centimeter minus this 12 centimeter. Understood? So 50 centimeter minus 12 centimeter, that will simply be 38 centimeter. Understood? And we have, now we also have image distance. How? The image distance, the screen is at 88 centimeter and this lens is as 50 centimeter. So image distance will be what? Image distance will be 80 centimeter minus 50 centimeter. Now frankly, weirdly, this is also 38 centimeter. So image distance is equal to object distance. In which case that happens? That happens when the image, when the object is placed at what? When the object is placed at 2f or radius of curvature, center of curvature. Understood? Now, if the object is placed at 2f, so 2f is simply 38 centimeter. Understood? 2f is 38 centimeter, and if 2f is 38 centimeter, so f will simply be 38 by 2, that will be 19 centimeter. So focal length of the convex lens is 19 centimeter. Understood? What else they have asked? Where will the image be formed if we shift the candle towards the lens at a position of 31 centimeter. Now what they did is, they changed the position of candle. They changed the position of candle as what? As 31 centimeter. So U is minus 31 centimeter. Understood? V was 38 centimeter and focal length, what will be the, what did they ask? Where will the image be formed? Okay, so we have to actually find the this image, of course. So this is 31 centimeter. This we have to find. Focal length we already have. Focal length is 19 centimeter. Correct? Focal length is 19 centimeter. So we'll just use lens formula. Understood? 1 by f equals to 1 by v minus 1 by u. 1 by v is what we have to find, minus of minus 1 by 31 centimeter, and focal length is 1 by 19. So from here you can easily find the position of image. Understood? If you just solve this LCM, you will find the position of image. Sorry. What will be the nature of the image formed if we further shifts the candle towards the lens? Ma'am, as the object is behind the focus, of this convex lens, then the image will be real and inverted. If the object distance is more than the focal length, then the image will be real and inverted, right? But as even in the first case, see, the focal length is 19 centimeter, but yeah, in this case, see, yes, in this case the object distance and the distance between object and lens is more than focal length, right? So we make a real and inverted image. But if the object distance now is less than focal length, object distance becomes less than focal length, then the image will be virtual and erect. Very simple, the image will be virtual and erect. That will be the sixth case of my convex lens. Understood? Clear? Okay, draw a ray diagram to show the formation of image in all cases. We have already done that. Okay, moving on. I guess this was the 9th question. Moving on, we have 10th question of the day, that is, a spherical mirror produces an image of magnification -1. So we are given magnification as -1 on a screen placed at a distance of 40 centimeter from the mirror. We have a mirror here. Keep in track, we have a mirror, not the lens, right? So the object distance is -40 centimeter. Understood? Write the type of mirror. See, magnification is -1. So we have to see where the image is formed. Understood? Let's see. See, magnification is -1. The very basic, you can see magnification is -1. If you want to solve it without solving, this is the way. Magnification is -1. -1 mane the image is real. One second. Magnification means the image is real and inverted. Right? Now real and inverted image is being made by only one kind of mirror, and that is concave mirror, because we know convex mirror never forms real and inverted, it always forms virtual and erect image. First part is already done. Okay. What is the nature of the image formed? Now, what will be the nature of image formed? That we can find from here. So, magnification for a mirror is -v by u. Magnification is given as -1. Minus v, we need to find, u is -40. So, v will be -40 centimeter. Right? V is -40 centimeter. That means this V is on the left hand side, which means the image is that, where is this? This nature. The image is real and inverted. Right? We can already see that from magnification, but this is the way you can find as well. Right? How far is the object located from the mirror? That we already found, -40 centimeter. Draw the diagram to show the image formation in this case. We need to make the image in this case. So we have a what mirror? We have a concave mirror. So this is my concave mirror. Right? Let's draw the principal axis. This is my, let's say this is the principal axis. Right? We are given the object distance is 40 centimeter. Now, one thing you need to see, object distance and image, just the distance, not the sign, both are 40 centimeter, right? Both are 40 centimeters. That means the U is what? U is center of curvature, because when the image is when the object is placed at center of curvature, only then the distance of image and distance of object is same, right? So this is center of curvature. That means this is where the object is being placed, right? And the image is already also placed on this. We have already found out that is minus 40 centimeter, right? So you can just say this, that a ray goes parallel, it passes from focus and it goes from here. Okay, you must use scale for that, right? Something like this. So your focus will be not here, your focus will be something here. Okay, use proper pen and scale for this, right? And then if another ray passes from the focus and it bounces back, and then it bounces back, it will come at the point, and this is your image. Okay, this is your image. So this is your object and this is your image. Understood? Clear? Okay, and make sure to do this on your concave or whatever mirror, so that you can you are telling them directly that this is the reflecting side. Okay, and we are done with the 10th numerical of this session. I have 2 more numericals and you will solve them. Give the answers in the comment section. This is the first numerical and then this is the next numerical. It is almost similar to the ones I have taught you all throughout this session. Now we are done with the most basic numericals of this session. Be sure to revise them. If you have any doubt, feel free to comment down, to contact us. We are always available for you, okay? And I'll be coming live, so you can ask your doubts there too. Till then, tada bye bye.